To study the effect of PET fiber, polyethylene terephthalate fiber, on geopolymer concrete by using GBBS and fly ash. Abstract: the demand of utilization of the waste product from the industries is at its peak, therefore, several experimental investigations have been carried out to examine their physical and chemical properties when they are used as a replacement material in concrete. In this investigation, the fly ash and GGBS were utilized to make the geopolymer concrete, and PET fibers or strands were present in it with various quantities. The fly ash and GGBS-based geopolymer concrete was utilized with equivalent amount, half fly ash and half GGBS, and PET strands were utilized in it. Volume division of fine totals/weight level of fine totals, with various rate, for example 0%, 2%, 3%, and 4% to consider the mechanical properties. The geopolymer concrete containing PET fibers were restored with two strategies, for example broiler relieving/oven curing, 24 hours at 600 C, and encompassing restoring/room temperature curing. The PET strands measurements was utilized relating to 45 perspective proportion 90 x 2 mm, length x width. The prepared samples were tested at 7 and 28 days. This study has been done on the fresh property, compressive strength, elasticity/tensile and flexure strength of PET fiber exemplified geopolymer concrete. The compressive quality improved a step by step with the joining of PET fibers. Rigidity and flexural quality tests gave huge improvement over controlled example. Keywords: geopolymer concrete, fly ash, GGBS, PET fiber. 1. Introduction. Concrete is the development material that is comprehensively utilized in development industry. Concrete is a man-made material, enormous zone utilized for development reason. Concrete is a blend of coarse total, sand, concrete and water. The solid is legitimate drawn-out period previously so. Advantageous mineral admixtures are joined in best quantum by the concrete change in immense property. The utilization of industrial facilities quander has upgraded in zone of development of solid production since, it's put at deficiency the ordinary utilization of naturalistic methodology. The ongoing past, significant examination considers have been performed to discover all conceivable reusing and use again strategy. Development useless materials, that is copper slag, fly ash, steel slag, iron slag, and others. Numerous materials have been conceded at better places in asphalt's establishment, roadway, and numerous development fields, ill-equipped item to the erection by conventional Portland concrete. A few nations are proving the quick amplification to the development processing plant that incorporates the use of an artificial methodology to the advancement of structure. Consequently, locators develop useless lead strategy to apply for replacement of fine total for select prerequisite. The useless material is utilized in the main secure area of development industry, which decrease the issues of ecological, issues of room and development cost. Utilization of useless materials as a replacement for sand and concrete in concrete characterizes recovery in mechanical characters correlation with common cement and have discovered their use in the various structures. It very well may be inferred that the geopolymer cement might be the material which can be utilized for the development reason and economical material for our development businesses and condition. Geopolymer concrete arranged by utilizing crude material of mechanical waste from warm force plants and steel ventures by the salt enactment of pozzolanic materials. Geopolymer solid wording was first presented by a researcher to be specific David Ovitz et al., 1984. 1988, 1989, 1994, 2005. To deliver geopolymer solid, we need the materials which have pozzolanic properties, for example, GGBS, which is a waste material from steel industry, Class C or Class F fly debris, which is a side effect from warm force plant and antacid-initiated arrangements by the blend of watery arrangements of sodium hydroxide and sodium silicate. The response of polymerization with pozzolanic materials utilizing soluble arrangements prompts a few cycles. The different cycles can be obliteration of covalent bond, disintegration, coagulation, gelation, buildup, and redesign, which at last outcomes in solidifying and polymerization of geopolymer concrete by expulsion of overabundance of water from grid. Geopolymer solid outcomes in items which transforms it math from undefined to solidify calculation structure. 2-liter Tor review. Duckson et al. 2007, examined that the utilization of cement is quickly expanding each day as the requirement for cover and financial exercises are expanding. Additionally, because of the globalization and industrialization, more infrastructural offices were created which utilize concrete. It has been perceived that the manufacturing of OPC discharges gigantic amount of energy and carbon dioxide to the general condition. Along these lines, it is fundamental to locate a substitute folio to create ecological agreeable cement. Rovnanik, 2010, investigated that restoring temperature has a significant impact on solidifying and geopolymerization of mineral-based geopolymer. At a mood and higher temperature, the example for all intents and purposes set in the initial 4 hours. Unexpectedly, the setting was additionally delayed for a time of 4 days when the blend was taken care of at temperature of at most 10 degrees Celsius, yet this doesn't influence the evaluation and properties of cemented geopolymer item at the age of 28 days. Quickened quality arrangement was seen on rock-based geopolymer restored at 40 to 80 degrees Celsius temperature. It merits referencing that the impact of temperature is dependent on term of restoring. Relieving for a shorter period in broiler didn't respect noteworthy changes in quality turn of events, however stretched out restoring cycle to at any rate 20 hours was the cost for an observable quick pace of response rate and brought about early quality picked up. Vjet al. 2010, studied the couple of varieties of strands yield more significant impact, scratched spot and break obstacle in concrete. For essential applications, fiber concrete has various novel inclinations when stood out from the ordinary assistant concrete and recorded as a hard copy. It has been represented that may look at bunches have investigated the effect of thought of fibers in concrete involving either 100% bond or fragmented replacement of bond by fly blazing remains. In the current work, an assessment has been had to consider the effect of volume of steel fibers on mechanical properties of geopolymer concrete orchestrated using 90% fly powder and 10% GGBS under incorporating and warmth-soothing conditions. Hassan et al. 2011, examined that solid in pressure and delicate in strain to beat this difficult strands are utilized in concrete. He took a shot at mechanical conduct of fortified cement with miniature manufactured strands. He arranged 4 blends, 1 without any filaments and staying 3 with 3 distinctive fiber measurements 0.32, 0.43 and 0.50% separately. He projected the solid shapes for the assurance of mechanical conduct, for example, rigidity, stress-strain connections, compressive quality, and shear quality. He inferred that a large-scale manufactured fiber upgrades the compressive quality fundamentally. For large-scale manufactured filaments at 0.33, 0.42, and 0.51% volume parts, a definitive shear quality was expanded by in any event 15, 45 and 65% separately contrasted with control radiates. Olivia and Nick Raz, 2011, dissected that the water penetrability of geopolymer concrete made with fly debris proportion of 0.36-0.46 exposed to broiler relieving at 60 degrees Celsius temperature for 24 hours. They found that geopolymer concrete demonstrated lower water porousness esteems, 2.45-4.65 x 10 to 11 m/s, than the standard cement in view of its denser blend and little between pore connect. They likewise expressed that the most significant limitation influencing the properties of geopolymer concrete was its water geopolymer proportion. Naidu, 2017, analyzed progressed work class F fly debris and ground granulated impact heater slag, GGBS, are utilized in comparable extents, Fa_50 GGBS_50, with basic activator arrangements. Manufactured strands, polypropylene and polyester filaments, are utilized at fiber measurement of 0, 0.2, 0.25, 0.3, 0.35, and 0.4% individually, and different progressed mechanical properties are tentatively contemplated. The greatest compressive quality of geopolymer concrete for 7 days, 28 days, and 90 days relieving period is 35.85 N/mm2, 46.81 N/mm2 and 52.65 N/mm2 individually by incomplete supplanting with ideal level of engineered filaments of 0.3% substitution. The most extreme split pliable specialty of geopolymer concrete for 7 DAYS, 28 DAYS, and 90 days restoring period is 3.27 N/mm2, 4.26 N/mm2 and 4.53 N/mm2 individually by fractional supplanting with ideal level of manufactured filaments of 0.3% substitution. 3 materials and methods. Fly ash. The fly ash is the residual obtained from the combustion of powered coal and transferred by flue gases and collected by electrostatic precipitation. It has surface area of 0.3 to 0.70 m2/g. Its particles are finer than cement particle. It is light gray, dark gray in color. Fly ash was obtained from Ropar thermal power plant. The Class F fly ash used is this research. It is low calcium-based fly ash, calcium content is low in it. The specific gravity of ash is 2.24. The annual production of fly ash in India is 225 million tons. Table 1 Fly ash chemical composition and its properties. GBBS. GGBS is a waste product obtained from the iron manufacturing plant. It is termed as ground granulated blast furnace slag. GGBS is produced when steel is heating at high temperature and waste is come out after that process and that waste is grind up. And powder is made, that powder is known as GGBS. It was obtained from Ecogen Industries Private Limited, Dehradun. The specific gravity of GGBS is 2.86. It is non-metallic and it is in slag form and powered into small particles that can be replace cement or fly ash. It is rich in calcium silicate and imparts strength to concrete. Nowadays GGBS-based cement is coming. PET fiber. PET bottles were acquired from the nearby Peace Cellar. At that point these bottles cut into long ropes. From that point onward, these ropes are cut into an angle proportion of AR45, for example 90 mm length and 2 mm broadness. The covering of epoxy gum has been done to shield the fiber from the compound assault. The level of PET fibers utilized in this examination are 0,2, 3, 4% volume of portion of fine total. It dependent on past the examination did on concrete-based cement. Properties of polyethylene terephthalate. Density 1.37 1.40 g/mm3. Melting point, 215-256 OC. Fine aggregate. It was gotten after strainer of fine total which went through 4.75 mm from zone 2. The fineness modulus of sand was 2.93 and explicit gravity was 2.68. Is 383-2016 code use for fine totals. Table 3 Sieve analysis of fine aggregate. Indian Standard Sieve. Fineness modulus equals 2.9. Coarse aggregate. It is obtained from a local source. This coarse aggregate used size 20 mm and 10 mm with specific gravity is 2.54. Aggregates 20 mm were used 60% of the total weight of coarse aggregate and 10 mm aggregates were used 40% of the total weight of coarse aggregate. Is 383-2016 code use for coarse aggregate. Water. Very less amount of water was used in the geopolymer concrete. Normal water was used to fulfill the demand for solid content present in the alkaline solution. It is according to the amount of solid content present in sodium silicate liquid. Mixture. As there was no specific code for making the geopolymer concrete, a study carried out from the past research work and from the IS codes is 456:2000 and IS 10262:2009. This mix was made. Curing. In this examination work, 2 sorts of restoring procedures were utilized. One is stove dry relieving and other is room temperature restoring. In stove dry relieving example, place in the broiler at 600 C for 24 hours, after that example place in the room restoring for the 7 days and 28 days testing. In the room temperature relieving examples were not put in the stove, examples were kept in the space for restoring for the 7 days and 28 days relieving. Two unique techniques for relieving were utilized to check the distinction between the stove dry restoring and room temperature relieving. In this sort of relieving no water is required, that is helping us to spare the water. The relieving utilized in the examination appeared in Figure 1 and 2. For results and discussion. 4.1 Compressive Strength Test. Compressive strength testing is done under Universal Testing Machine, to determine the strength of the different grade of concrete by casting cubes of size 150 x 150 x 150 mm, under overdrying curing and room temperature curing. All the test samples were prepared and tested according to code IS 516-1959. The results of the compressive strength show good up to 3% PET fibers adding. After that the results were converted into lower side as shown in graph 5.1a, and 5.1b. The overall result shows that the oven dry curing samples shows good strength as compared to the room temperature cured samples. 4.2 Flexural Strength Test. The main aim of the flexural strength test to measure the strength of concrete by casting a beam of size 500 x 100 x 100 mm. In this test, the crack width is measured with the ultimate load on the prepared samples. The three beams were casted to calculate the flexural strength with the help of Universal Testing Machine as per code IS 516-1959. The result of flexural strength is higher for geopolymer concrete with PET fiber as compared with the geopolymer concrete without PET fiber. Strength of geopolymer concrete increase with the increase in the percentage of PET fiber up to 3%, after that it starts maximum flexural strength was obtained at 3% PET fiber. Curing. Graph 2 showing the results of flexural strength test, room TEMP curing. 4.3 Split Tensile Strength Test. The split tensile test is a type of destructive test in which a sample is destructed to check the strength of the material. The size of the specimen is 150 mm diameter and 300 mm length of the cylinder. The compressive testing machine is used for testing the split tensile strength. All the procedures of this test were performed according to the code IS 5816-1999. Percentage of split tensile strength. Percentage of PET. Split tensile strength. 4.4 UPV, ultrasonic sonic pulse velocity, test. It is a type of non-destructive test and this test helps us to find out the quality of the concrete with the help of ultrasonic sonic pulse velocity machine according to IS 13311, Part 1, 1992. Test conducted on cubes after 28 days for 24 samples. Pulse velocity in m/sec. 5 Conclusion. 5.1 Compressive strength. The maximum compressive strength result for geopolymer concrete with 3% PET fiber for 7 days is 24.79 MPa and 28 days is 35.58 MPa in oven drying curing. On the other hand, the maximum compressive strength result for geopolymer concrete with 3% PET fiber for 7 days is 24.38 MPa and 28 days is 32.39 MPa with room temperature curing. The strength is maximum for both oven drying curing and room temperature curing with 3% PET fibers. 5.2 Flexural strength. The strength of oven drying curing and room temperature curing shows maximum results with 3% PET fibers adding in geopolymer concrete. The strength values for overdrying curing for 7 days is 5.48 MPa and for 28 days is 7.62 MPa. Similarly, the values for room temperature curing for 7 days is 4.20 MPa and for 28 days is 5.93 MPa. 5.3 Split tensile strength. The split strength of oven drying curing and room temperature curing shows maximum results with 3% PET fibers adding in geopolymer concrete. The strength values for overdrying curing for 7 days is 2.98 MPa and for 28 days is 3.96 MPa. Similarly, the values for room temperature curing for 7 days is 1.70 MPa and for 28 days is 2.54 MPa. 5.4 UPV, ultrasonic sonic pulse velocity. In UPV test, the maximum velocity value shows for overdrying curing is 3850 m/s, the values for room temperature curing is 3630 m/s. The maximum values show by adding 3% PET fibers.